Happy New Year's, ladies and gentlemen. My name's Sarel Anbar, and today I'm going to be showing you how to do question 4 of AP Calc AB FRQ 2010. Now, looking at this problem just to start out with, we see that it's our classic two-function integration problem, where our two functions are y equals 2 root x and the horizontal line y equals 6. So our first question is simply to find the area of R. Now, conceptually, the area of the region is going to be the area under the bigger function minus the area of the smaller function. Will leave us with a difference, which is this. And the reason I'm integrating from 0 to 9 is because that's where the two functions intersect right there. So I have the upper function minus the lower function. And note that you can also write this like this separately. It's the same thing, but in terms of the calculations, it's easier to write it as 1. Okay, so now if you have completely forgotten how to integrate it, that's not the best, but it's still acceptable because you get a point just for remembering that. Okay, so now our antiderivative. So we're going to take 6x, so that's 1, that's just going to be 6x, minus, this is 2x to the 1/2. So this is going to go to 6x minus 2 divided by 3/2 times x to the 3/2, which is equal to 6x minus 2 times 2 over 3, x to the 3/2, which is equal to 6x minus 4/3 x to the 3/2, and we're going to evaluate this from x equals 0 to x equals 9, and don't worry about the x equals 0 because we're only working with variables, and the 0 will just make this whole thing 0. So we just need to evaluate for 9. So we plug in 9, and the square root of 9 is 3 times 3 is 27. So times 27, this goes to 9, this becomes 54 minus 36, and the difference is 18. So that's our first answer. So you're going to get a point for doing this right here, the integrand. Then you're going to get a point for doing the actual integration, and a point for getting the answer right. So if you can just do this right there, you get 33% for number A, for section A. So now if we look at B, it's asking us for the volume if the solid is rotated, if R is rotated about the horizontal line y equals 7. Now y equals 7 is going to be up here, and immediately we see that this is a washer problem. So it's going to be the area of an infinite amount of larger circles minus the area of an infinite amount of smaller circles. And if you have the area of an infinite amount of circles, that becomes your volume because you have slivers that add up. So we're going to not utilize our shell method because the shell method was designed to do just this. And our general form is here. You have a constant. This is just the difference between the constant and the function. And the function here, the function that's farther away, the outer function from the constant, is going to be the 2 root x. So you subtract root x. This doesn't actually matter, the order right here, because we're going to square that. But this following part, it matters that you get the outer function minus the inner function, which in this case is 7 minus our second function, which is 6 squared dx. And that's all there is to B. You don't have to solve it out. And you get a point just for this part right here. Sorry, this is 0 and 9. So just for this part, this is going to be 7. Just for that part right there, you get 1 point, and then you get 2 points for this following part. Now the last part, C, is asking us for cross-sections. And typically, cross-sections are asked with respect to the x-axis, but this x-axis is also known as y equals 0, so don't get fooled by that. This one's asking for respect to the y-axis. Another way to say the y-axis is x equals 0. So we need to take this upper function isn't a function anymore, it's just a bound. It's our upper bound of this vertical integration. So what we have to do is this is the same region, but instead of looking at it this way, we're looking at it like this. So it's just one function in terms of y. So to do that, we're going to square both sides here. Y squared equals 4x. So x equals y squared over 4. Now the cross section we're using is a rectangle. A rectangle's area is given by its base times height. We've established that the base in this case is right here. The problem says that the height is 3 times that of the base. So the area is going to be this base times 3 times that, or the height. And we're going to end up 3 over 16 y to the 4th. Now, all we're doing is taking the integral of that in order to find the volume. The integral is not, this is careful, you need to make sure you don't integrate from 0 to 9 because it's not horizontal anymore. We're looking at it vertically. It's 0 to 6 because that's where this function stops or intersects with our bound. So the volume is going to be given by this. And note, you don't have to go any farther than this, and you get 2 points for the integrand and 1 point for the answer. Alright, some important information I want to let you know. This is an extremely popular problem. The AP writers love this. So whether you love it or hate it, you have to learn how to do it because it's shown up in over 50% of the free response questions I've seen, including your 2003 number 1, 2004 number 2, 2005 number 1, 2006 number 1, 2008 number 1, 2009 number 1, and 2011 number 3. So even if you don't know how to do a particular problem or you don't know how to integrate, do the best you can. Let not your heart be troubled because the AP graders are really looking out there to give you as many points as they can. I appreciate you coming out to watch the video. I hope you subscribe to my YouTube channel, follow me on Twitter, and I hope you've enjoyed the video lesson. Thanks for watching.